Good morning, guys. Good morning and welcome to Unacademy. This is Abhijit, and today we are going to discuss about the again translation topic. Okay, so though we already discussed about the translation, it's a theoretical part. Now today we're just going to discuss you can say the thoroughly discuss the MCQs on a translation. Okay, so guys, let's say this is a Crack Maharashtra CET channel. It is running with a 2021 syllabus. I mean, the as per the new syllabus, MST CET new syllabus, the complete reduced syllabus and the complete uh, considered. I mean, the syllabus which is considered by the CET cell. Okay, uh, because we know that due to the COVID-19, Maharashtra government already deduced few part of your syllabus. Okay, so that is not going to be considered here. Okay, so timing of lecture is in the front of you, and it's on the daily basis, so you can see the lectures. You can attend the lectures morning and the evening session also. Okay, so guys, let's say uh, before starting the lecture, it is necessary to know about me. This is Abhijit Madkar. I have more than 6 years of experience in the field of biology and also crack net CSIR uh, with All India rank 60 from Life Science. We are here on the India's largest platform, the Unacademy. If you want to enjoy more, the Unacademy or the learning, so it is necessary to install this app in your mobile. This app is available for both the Android as well as the iOS, and the link is given below in the description of this video, so you can download the app from there. Okay, so guys, this is Telegram app. If you have a Telegram app, then just go and click on the link which is given below in the description. That is the group link for the group Telegram channel. Okay, so that Telegram channel will help you to attend the lectures live, because the links for the lecture and the timing of a lecture is given there in the Telegram app. Okay, so this app will also help you for the different things like notes and the MCQs to attend, and it will definitely help you to improve your score, guys. Okay, so guys, here is few things. We call it a subscriptions from Unacademy, so it will help you to boost your score. How? Let's see. The offline facilities, MCQs practice, dedicated doubt solving session, and the uh, attend live session of your favorite educator. This complete at this type of the facilities are comes under this subscription. Okay, so other facilities comes under the subscriptions are given below in the description of this video. You can see it. Okay, so let's say for the 12 month the fees of a subscription is a 14,850 rupees, and for 24 month it's a 21,600 rupees. So guys, uh, there are lots of facilities comes under the subscription, we already discussed. But if you use the capital Abhijit as a subscription code, so it will give you the 10% discount in a fees. Okay, so here you will have the 1485 rupees discount, and here you will have the 2160 rupees on a discount. Okay, so if you take the longer subscription like a 12 month or 24 months, it's a uh, about 1000 or less than 1000 per month. But if you take the smaller subscription, it will definitely had the more fees. Okay, so for a 6 month it's a 12,000, and for a 12 month it's a 14,000. So only 2,000, if you add 2,000 rupees in a 12,000, so it will give you the complete subscription of a double time. Okay, so we just call it like a one subscription and the unlimited use of an academy app. Okay, so when you take a subscription, make sure that you will take it for a longer, I mean the subscription should not be end before or prior to the examination, so you will have the more chance to attend the MCQs test and other things. Okay, so MCQs practice is very important, guys, and we know that the analysis is more important. So we have an analyzer here. Okay, so after the each and every test, uh, the analyzer will show you the result, like the how many questions you make a correct, how many questions you make a incorrect, and the which type of questions you make a correct and which type of question you make a incorrect. Okay, so guys, it will give you the idea to decide the direction of your study. Okay, so that's why uh, when you take a subscription, take it longer and enjoy the education. Okay, so thank you very much, and let's start with the translation and the questions on the translation. Okay, so this MCQs will definitely help you in examination. So the first MCQs in the front of you is which is required for the protein synthesis. Okay, so the protein synthesis is a process, we call it a translation. Actually, this is a process, we call it a translation. Okay, so initiation codon. So we know the translation start on mRNA. So here is a first codon, we call it a start codon, and here is a last codon, we call it a termination codon or a stop codon. So these two codons are required to start and to stop the process. Okay, so the initiation codon is a correct answer. Then the peptidyl transferase. So we know the process is conducted by the ribosome. Okay, so this ribosome is again necessary thing. So it synthesized a newly synthesized peptide is here. So here is actually the P site. Here is A site and E site. So this P site is involved in the making of a peptide bond. Okay, and that peptide bond, the making of a peptide bond is due to the activity of a peptidyl transferase. Then GTP. Yes, GTP is required. So whenever the RNA shows the catalytic activity, so most of the time GTP is required for the energy. I mean, it is used as a energy source of energy by the uh, ribozymes. Ribozymes means any RNA which is having the catalytic activity. So most of the time, if RNA requires energy, so they use GTP instead of ATP. Okay, so this all things are correct, and that's why your answer should be the all of these. Okay, so let's say amino acids are carried by RNA by its. So RNA, we know which RNA that is involved in an amino acid carrier. So the tRNA. That's why we call it a transfer RNA, because it carries amino acid. So it will looks like this. We know this model is called as a so it is always placed on the OH group of a 3 prime, and amino acid is here now. Okay, it is called as acetylation of a tRNA. Okay, sorry, amino acid or the charge of amino acids. Okay, charged tRNA. So on 3 prime end, this is anticodon loop. It is called as anticodon loop, and this is called as anticodon arm. Okay, so these two loop we will see what are the variable loop is here. Actually in this diagram I do not draw it, but now it's present. Okay, it's called as a variable loop. The length of this loop is a variable. I mean, it's a different in tRNA. It may be shorter or it may be a longer. Okay, so depending upon the tRNA, so we called it a variable because it is not fixed. So your correct answer is a 3 prime end. Okay, so at the 3 prime end it is attached, 5 prime end is always open. So here is three nucleotide which is unpaired. Unpaired means not paired with a 5 prime name. Okay, so total, if you see this stack of a or this piece of a tRNA shows 7 nucleotide piece. It's a 7 nucleotide piece. For having pairing with a 5 prime end, and the three are unpaired, and these three unpaired shows, I mean, the binding site of amino acid. Okay, so at the 3 prime end, RNA in a transfer of amino acid. Okay, so we already discussed it's correct. Uh, it involves what I already told you. There is a three base pair. Here is a three base pair. Sorry, not a base pair, nucleotides already we written here. So that's why I draw this diagram, because I want to explain the next question also. So these three nucleotides are very necessary to be a single, because if it pairs, so it causes a problem uh, with the binding of amino acid. Okay, so that's why it's unpaired here at the end. So the your correct answer is, let's see the all option. First of all, discuss the all option. CCA nitrogen base is a present. Okay, so it may be correct. G nitrogen base is a present. So we know there is a three non-paired or unpaired nucleotides. Okay, so it may be the more correct as compared to the G. Okay, the exact type of a nitrogen base are not unknown. Okay, so yes, it's unknown, so it is not correct. Nitrogen bases are absent. It doesn't happen with RNA. Okay, so this is not correct. So your more correct answer is a CCA. Okay, more correct answer is CCA. So this is actually sequence CCA which is present here. CC and A. Okay, so here is actually sequence we called it CCA. Okay, so the correct answer is CCA nitrogen base is present. See. Next question. Sickle cell anemia is a cause by change in. Sickle cell anemia, we know guys, this is the disease caused by due to the mutations. Okay, mutations in a beta chain. Let's say the more than two genes in a genome, it is caused due to the more than two genes in a genome. So we know it's a single gene disorder. So only one gene, that is the gene of a hemoglobin is damaged. So it is not the more than two gene disorder. Okay, so it is not polygenic or the multigenic. It is a single gene damaged disorder. Okay, so first option is absolutely the wrong. Sixth codon is caused by the change in a sixth codon of a beta chain of hemoglobin, sixth codon of a alpha chain of hemoglobin, and both chain of hemoglobin. So both chain of hemoglobin is absolutely wrong. So alpha and beta, one of these is answer, and the correct answer is your beta chain. Okay, so the beta chain, it is single gene disorder and causes due to uh, the change in a sixth position of a beta chain. Okay, so sixth position of a beta chain, and it is caused due to due to the change in amino acid. So it the change or the uh, amino acid is a changed in the protein, because there is a change in a codon. Okay, so the only single A is replaced by the T in a codon, and that's why it causes the very dangerous disease, the sickle cell anemia. So we know that when you study the genetics, so that time you already discussed about the sickle cell anemia. If the homogenic uh, recessive is there, so it should be a die. Okay, so this is the sixth position beta chain damage disorder. Okay, so uh, the beta chain, the gene for a beta chain is present on the dash dash chromosome. Okay, so after the lecture, go and find it. So it is present on the which chromosome. So it may be the question in examination, so be prepared for that, guys. Okay. Which of the following is called as adapter molecule? We know the adapter molecule. Why it is, first of all, the why the molecule is called as adapter, because it plays a main role or the important role between the nucleic acid, uh, a message, and the amino acid. So which molecule plays the main role between the conversion of a nucleic acid to the amino acid? That is the translation process, and your answer is a tRNA is called as adapter RNA. Okay, so your adapter molecule is nothing but the tRNA. Degenerate codes are when, okay, so degenerate, this word is used for the which sentence which is given below in the option. Okay, so let's see. The codon is a degenerated after the synthesis of a protein. One codon can code for more than one amino acid. The codon is a non-functional and also called as the nonsense codon, and the same amino acid can be coded by more than uh, one triplet codon. Okay, so the codon is always a triplet. We know that. Hmm? So your correct answer is, guys, last one, because degeneracy, the degeneracy of codon is nothing but the one amino acid is a code by the more than one codon. It happens because if you see the number of codon in our body, it's 64. So out of that, three are the stop codon. So it codes for nothing. That's why sometimes called as a nonsense codon. So the codon may be the nonsense. Okay, so 64 amino acids out of 64, 3 stop codon, just minus it. The remaining codons are 61. It's codes for amino acid. Amino acids. Okay, so the 61 codons codes for the 20 amino acid, standard amino acid. So the 20 codon, 20 amino acid and the 61 codon, maybe, I mean it is very clear that the 20 amino acid code by 61 codon, that means there is a more than two, more than three codon codes for a single amino acid. Okay, more than three codons code for single amino acid, and that's why the process where the one amino acid is a code by more than one codon is called as a degeneracy of a code. Okay, so degeneracy of a genetic code was found by, so it is found by the Bernfield and Nirenberg. Okay, so Barenfield and the Nirenberg was the scientist who found the degeneracy. Okay, normally BUG uh, is a specific codon for the valine amino acid. Okay, so the normally when GUG is there, so it always codes for the valine. So three letter abbreviation for valine is a VAL and one letter abbreviation is a V. Okay, but when AUG is a initiation codon, then it specifies which one of the following amino acid. So AUG, which is also called as initiation codon or the start codon, it codes for. So it always codes for, AUG always codes for methionine. Methionine. Three letter abbreviation for methionine is a MET and one letter abbreviation is a YAM. Okay. So methionine always codes for the AUG. If it is a prokaryotic, so it's a formyl methionine. Okay. So formyl group is attached to the methionine, so it called as YAPMET. and in a eukaryote it's only methionine met. Okay, so guys, please keep in mind that your start codon always codes for methionine and your stop codon codes for nothing, and that's why sometimes called as a nonsense codon. Okay, so the meaning of a nonsense here is do not have any uh, a facility to code for the particular amino acid. So always there is always the termination factor which come and bind to the stop codon. So we know there are three stop codons. It come and binds to the stop codon, and when it binds to the stop codon and your ribosome slides on the complete uh, the mRNA and comes to the stop codon, so it automatically uh, detached from the mRNA. See, its small subunit is now the separate, large subunit is a separate, and the very important thing, your newly synthesized polypeptide is also get separate from this assembly, and now your protein is now completed and it's free to move. Okay, so after the chaperone, it is packed inside of the vessel, and it started its journey from the RER to the Golgi complex, and from the Golgi complex or the Golgi bodies to the target place. Okay, so depending upon the protein, if it is made in a cytoplasm, so it is transported, it's a target place again. Okay, so uh, this is the complete the process of making up a protein. So guys, let's say when the translation start, so if you see the main place where the translation start is a RER, rough endoplasmic, that's reticulum, and that's why it's a rough endoplasmic, because the ribosome is present, uh, and due to that the endoplasmic reticulum is looks like a rough. Okay, and the second site is a cytoplasm. mRNA in a prokaryotes are prokaryotic cell, means a bacterial type of a cell. The mRNA is a polycystronic, monocystronic, replicative, and none of these. So which one is the correct? So replicative is so we know this is not answer. It may be the monocystronic or the polycystronic. So we know that operon. So first of all, what is meant by polycystronic and what is meant by monocystronic? Let's see. For example, this is a mRNA. Okay, it codes for the one protein, X protein, whatever it is. Okay, and now here is again the mRNA. So this mRNA codes for three proteins. So why I am drawing protein like this? Because they are like this. Okay, so don't be confused. Proteins are looks like this. It's just cartoon what you see in a book like this. The your enzyme is looking like this. So it's just cartoon to understand. Actually, it looks like this. So proteins are a thread. It's a look like a thread, the complex thread made up of the amino acid. So the single mRNA which converts itself into X, Y, and Z, three proteins. It is called as a polycystronic, and it is called as a monocystronic. And your operons are polycystronic. We know that the lack operon is responsible for making up three proteins. Sorry, making up three proteins, or the your lack operon ends in three proteins from the one mRNA, and it is I mean this facility is present only in a prokaryotes and not in a eukaryote, guys. Okay, so the polycystronic mRNA is a common thing in a prokaryote, but it is not present in a eukaryote, because our DNA is transcripted in a single mRNA, for example, and that mRNA, single mRNA results into the single protein. Okay, so means one type of a protein, not a single protein, but one type of a protein. Thousands of lakhs of proteins are synthesized. If you see the half life of mRNA, it's just 2 minutes, guys. Just normal 2 minutes. In a 2 minute, the your mRNA already cut. I mean, it is degraded by the cytoplasmic things. Okay. The codon, which has a dual function, is the codon which is having the dual function means two functions. Two functions. So codon is having only what is the main function of a codon? It codes for amino acid. It codes for amino acid. So what is meant by dual function? So the codon which also work for the different role rather than the coding of amino acid, and we know the AUG is also called as a start codon. So dual role. What is the second role? First is a code for methionine. Okay, so let's write here dual role. First is codes for methionine, and the second is start codon. Act as a start codon. Act as a start codon. The hypothetical mRNA, the codon would normally be translated as follows. So hypothetical mRNA shows the first sequence UUU codes for leucine, UUG codes for leucine again, UUU codes for valine, UGU codes for cysteine, UAU codes for tyrosine. Guys, don't go with this codon and the codes for which amino acid. It's already said that the hypothetical it should be a different. Okay, so this is not the correct sequence of codes and the amino acid which is coded by okay, so it may be the correct, it may be the incorrect. Don't go with it. Just try to understand the question. If single G is a single G residue is inserted between the second and the third, so this is our first codon. First, this is second, this is third. So one G is incorporated here. Between the second and the third codon. Okay, so the third and second codon we already incorporated. So what will happen? No protein will be produced. A complete different protein will be produced. The first amino acid will be the same, but the remaining will change. The first amino acid will be changed, but remaining will be the same. Okay, so let's see, guys, what happened. So whenever the question this like this, the question like this is come or you appeared in examination. So first of all, try to understand the question. Okay, so what they are talking about? They are talking just the addition mutation, like where the one base pair is added, and because that what happened so we know the three nucleotides comes together to form a codon. So because of this what happened, so this is the first codon, it codes for first amino acid, so there will be no any change. Second codon, so there will be no any change. So a third codon will be changed like this. Okay, so GUU, and the fourth codon is again going to be a change, UUG, and the fifth codon again going to be a change, UUA. Okay, so if you see the next sequence, they never told about the next sequence. So it is not completely correct that a complete different protein will be produced. Okay, so this is not answer. No protein will be produced. So maybe due to this the degeneration of the stop codon, because this sequence will definitely change your stop codon sequence, so it may happen that the protein is not detached from the ribosome, and it will be digested. But they never told anything about the stop codon, so it is also not correct. Okay, so the first amino acid will be the same, but remaining will change. So exactly, the first and second will be the same, but remaining will change. Okay, so this may be the answer. Let's see the last one. The first amino acid will be the change. So the first amino acid is not going to be a change, because there is no any change between the first and the second codon. So the first two amino acids are not going to be changed. Okay, so the first two amino acid, if the sentence was like the first two amino acid will be the same, I'm talking about the third option, will be the same, but the remaining will change. So the first two, if they use the first two amino acids, so it is more correct. But now we do not have any two, and we know that when you are talking or you are moving with MCQs, so don't be like which one is correct and which one is correct. Okay, so don't do that, guys. uh, the MCQs or the pattern of MCQs is not for to select the correct and incorrect. Okay, so guys, it is always about the most appropriate answer. What is the most appropriate, what is very close to the question. So this sentence is very close to the question or to the answer, and that's why our answer is a third. Okay, if you write this in a theory examination under this question, so it is not correct. If it is for 1 mark, so so no one is give you 1 mark because of this first, because when you add the G between the second and third, so that means your second amino acid is also not going to be a change. Okay, so it is not correct for the uh, theoretical exam. But when you answer like for 1 mark in a theory examination, so the first amino acid will be the change, will be the same, but remaining change. So it is not correct. First two amino acid will be the same and the remaining will change is a correct answer. Okay, so let's see. So your answer for this question is a C. Synthesis of a polypeptide chain begins at. So synthesis of polypeptide chain means synthesis of amino acids, chain of amino acids. So when mRNA is completely translated by the ribosome, so the chain, newly synthesized chain, is like this, and it is always having the first amino acid here and the last amino acid here. Where first amino acid is always methionine. Okay, so it looks like, for example, I'm going to zoom it now. The first amino acid is zoomed, so it will looks like this. Attached to the N of second amino acid. So this is R3 third amino acid, again having the so guys, when you draw it draw like a trans arrangement. Okay, so R3 is here, R1 is here, and R2 is there. So the R group are always arranged like a trans. Okay, so nitrogen, it is having the hydrogen here. Okay, so I'm not going to draw everything, just try to understand. So this is your first amino acid, this is your second amino acid, this is your third amino acid, Okay, so they are in different planes. So the first amino acid always shows a nitrogen group open, amino group open, and the last one always shows the carbon COO minus or the COOH group open. Okay, so when the protein is completed, so it is always having the two type of end. So the first amino acid which is open, which is having the open amino group, we called as N terminal, and the last amino acid is always shows the open COOH group. Okay, so the C terminal, and the N terminal which is always synthesized at the beginning, the first thing. Okay, so N terminal is your always first thing. Okay, degeneration of a genetic code is attribute to entire codon, first member of the codon, second member of the codon, and the third member of the codon. Okay, so the degeneration of genetic code is attribute to. So guys, it is actually the about the oval hypothesis. So member of the codon means, for example, 1, 2, and 3. So this question is not the completely correct. Okay, we can say they're not completely correct, but I appeared this question in the one book, so I just decide to take it in the our study. Okay, so it is about the actually when your tRNA binds to the for example, this is the loop of anticodon loop of a tRNA. So don't I'm not going to be a very detailed structure of a tRNA here, and which is having the hydrogen bonding between the codon and anticodon. So degeneration means the codon which is showing here the inappropriate hydrogen bonding. Inappropriate hydrogen bonding means we know that there is always complementary bonding. So A is always in the front of U and G is always in the front of a C, or if there is a C, it is always in the front of a G. If there is a U, it is always front of the A. Okay, so not like that. If the bonding is not like that, the purine and pyrimidine are not going to be a bond here in the third codon. So this third codon is actually not a good in making a bonding in a codon and anticodon, and that's why the third member of a codon is always shows the degeneration of the genetic code. Okay, so let's see where it is always about the oval hypothesis. If what I am talking about is about the oval hypothesis. Okay, so let's see the degeneration actually. Degeneracy of a codon we already discussed before the few questions. Okay, so most of the actually the question come in examination was the about oval hypothesis when you are talking about the first member, second member, and the third member. Okay, so I just select this question because of these three options: the first member, second member, and the third member, because they always get confused you with a degeneracy with a oval hypothesis or oblong base pair. We call it a oblong base pair. Okay, so don't we get confused with the oblong base pair. It's a not a oblong, it's a degeneracy. We know the amino acid which is code for more than one codon is called as a degeneracy, and it is due to the entire codon. Okay, so not a first member or the second member or the third member is responsible, but the entire codon is responsible for the degeneracy. So the correct answer is entire codon. Let's see the next one. After reaching the cytoplasm, mRNA binds to the after reaching the cytoplasm, mRNA binds to the cytoplasm, or you can say the RER. mRNA is always binds to the ribosome, we know, and that's why the question is like the options are like this: 40s particle of ribosome, 60s particle of the ribosome, 70s particle of the ribosome. So it is now the difficult for you guys if you don't know the sequence of a binding of a ribosome. Okay, so there is always small subunit which bind first. Small subunit, when it binds with the first tRNA having amino acid, charged tRNA bind, and then in the next step it always having the GTP here. Okay, and when in a next step your large subunit bind on this. So this is amino acid. Okay, and in this binding the GTP is converted into the GDP plus PI. So this is GTP which is converted into GDP plus PI, and then large subunit bind. So the first your answer is a small subunit, obviously it's a small. Okay, and 60 plus 40 is equal to 80 years in eukaryotic cell. So they are talking about the eukaryotic cell also. Okay, so the 40 years particle is a correct answer. It's a small subunit of your ribosome, and it binds first before the starting of a translation process. In a genetic code, in a genetic code dictionary, how many codes are used to code for all 20 essential amino acids? So we know there are 64 codes. Why 64? Guys, let's see. We have 20 standard amino acids. Okay, and we have only four different type of combinations to make a code: A, T, G, C. So if you use A as a code for one amino acid, so we will have only four codes for 20 amino acid, and so it is not possible to use 4 code for 20 amino acid. Okay, so if codes are more and the amino acids are less, so it is possible, but one code if is going to be act as a the reference for the more than one amino acid, so it will definitely uh, result into the mistakes. Okay, so that's why if we take uh, two of them, any two of them as a code, so it will results into the 2 raised to 2. Is it correct? Is it correct? So 4 raised to 2. Okay, so 16 amino acid again. So 4 raised to 2 means 16. So 16 codes for 20 amino acid, so it is also not going to be a work. So we decide, I mean the nature decide 3 nucleotides or the 3 base pair as a single code, so it will result into the 64. And that's why for 60, from the 64, this is act as a other codon. 64 codons combination may be possible, I mean the completely possible from this 4 codes. Okay, so this 4 code result into the 64 different type of codons, and that's why your answer is not a 64, because out of 64, 3 are the stop codons. We also called it a nonsense because not a code for anything, and that's why it's a nonsense codon. Okay, so result into the 61 codons. So the correct answer is 61. Okay, because of 3 stop codons, it is code for nothing. It is not going to be code any amino acid, and we call it the nonsense of the stop codons. So answer is 61. During protein synthesis in an organism, at one point the process come to halt. Okay, so during the protein synthesis, the process is come to a halt at the last point. Select the group of a codon from the following, from which any one of the three could bring about this halt. Okay, so they are talking about the stopping of the process, and they are talking about the codon which called it a stop codon. Okay, so UC and UAC, is it stop codon? So no, UUC, UUA and UAC, so it is also not correct. UAG, UGA and UAA, absolutely It's a stop codon. These three codons are acting as a stop codon, guys. These three are acting as a stop codon. And your start codon. So stop codons, three stop codons are uh, UAA, UAG, and UGA. Okay, and your start codon is always one, AUG. It's a AUG and codes for a methionine. It codes for nothing. Which of the following antibiotic inhibits interaction between tRNA and mRNA during the bacterial protein synthesis? Which of the following antibiotic inhibits interaction between tRNA and mRNA? So the binding of tRNA with the mRNA is uh, inhibited by which of the following antibiotic? So I know that most of the people uh, do not have idea about this question. So guys, write it down. A neomycin, which avoid the binding between tRNA and the mRNA. It always interfere with the binding between tRNA and the mRNA. Okay, so it's a neomycin antibiotic. Most of that. So guys, most of the things, I mean the drugs are interfere with this central dogma. Okay, and if you talking about the antiviral drug, they are always interfere with the replication process. Okay, so the more than 90% antiviral drugs interfere with the replication process. Okay, otherwise they will not going to be work because the machinery is our. Okay, and that's why the viruses are called as molecular biologist, the scientist which is molecular biologist. These molecular biologist scientists always call it the molecular hackers. Viruses are the molecular hackers because they do not have anything, guys, except of the DNA or RNA, that is the genetic material. When they enter with their genetic material, or the only genetic material is going to be entered in the particular cell, that is the host cell, so they completely use the host cell. I mean, the that genetic material is going to be used each and every part from your cell. Okay, so they do not have a protein, they do not have own enzymes, they do not have own ATP, they had nothing in their body. The complete cell is hacked by the viral genetic, and then uh, our cell start working for a virus, and that's why it is called as the molecular hackers. Okay, so let's say next question. The binding of the large subunit of ribosome to the mRNA requires the binding between ribosome and mRNA, it required. So I already told you, whenever the RNA is going to be working as a catalyst, or when RNA requires energy, so most of the time it use a GTP. Okay, so when your small subunit binds, so it bind with a GTP, and when large subunit come, so that time this GTP is come out in the form of a GDP, and then large subunit binds. So this is the complete process, guys. Okay, so let's see, in which of the following step ATP is converted to AMP? ATP is converted to AMP. So let's see how the ATP is hydrolyzed. ATP is hydrolyzed into the ADP plus PI. So this is one thing. Second thing, ADP can be hydrolyzed into the AMP plus PI again. Okay, so this is one thing. And the second process to hydrolyze the ATP is like this. ATP is hydrolyzed to the AMP plus PPI. So this is called as inorganic phosphate, and this is called as a pyrophosphate. It can be further hydrolyzed into the Pi plus Pi. so two inorganic phosphates. Okay, so it may happen inside of a cell. So when this process happen, ATP to direct AMP, so it required tremendous amount of energy, and that's why the ATP is directly hydrolyzed into the AMP, and then PPI is again hydrolyzed into the PI, and the both step, the energy which is coming out in a both step is used for a single thing, like the synthesis of DNA. In the polymerization, we know DNA use DNTPs. DNTPs means the all things like a GTP, CTP, TTP, and ATP. All things are in the form of a triphosphate, and DNA required only one phosphate. So still it uses a TTP. The triphosphate, because when the triphosphate is converted into the monophosphate, the energy which is coming out is used for the process, and again the PPI is hydrolyzed and the complete energy is used in the process of making of DNA. Okay, so let's see which option is correct. Binding of large subunit to the mRNA. So we know that the before one step we already discussed here, the binding of a large subunit required GTP. Okay, so obviously, the binding of a large subunit to the mRNA, it required energy, but not ATP to the AMP. It requires GTP. Here is the proof of GTP. Okay, so the first answer is incorrect. Amino acylation of a tRNA. So what is meant by amino acylation of a tRNA? So let's see. For example, this is a tRNA, chlorolip model of a tRNA. Okay, and this is 3 prime plus amino acid. So in the next step, it looks like this. Amino acid. So now it is bind to the 3 prime. Okay. So it required ATP and finally convert into the AMP plus PPI. Okay. So this is correct. Making a peptide bond. No. Okay. So this is not answer. And the binding of small subunit to the mRNA, it doesn't require anything. It just required the initiation factors. Okay, so let's see how. So your small subunit comes with a initiation factor IF1, initiation factor 2, and initiation factor 3. So these three things comes together and they bind here. Okay, with a tRNA and GTP. Okay, so it doesn't require the energy and the other things. It just required the sequence, that is the start codon. Not the complete start codon, but the sequence before the start codon. So in prokaryote, if you see, it's a sorry, Stein-Dahl sequence, and in a eukaryote, it's a G prime capping. The 5 prime G capping. Okay, so not G prime capping, it's a 5 prime G capping. Guanine triphosphate at the 5 prime. Guanine triphosphate, and at 3 prime, so polyatyl adenine, polyadenine in a eukaryote. Okay, so in prokaryote, it's a let's see the question. In a prokaryotic ribosome, in a prokaryotes, ribosome binds to the mRNA at the site. So I already told you that the answer, Stein-Dahl sequence. Okay, so it always binds to the Stein-Dahl sequence. Stein-Dahl sequence is present before the coding region of mRNA. So it's a coding region. So it is going to be as the protein untranslated region untranslated region, and this is called as a translated region. Translatable region. Okay, it is untranslatable, but at the 5 prime, and this is at the 3 prime, so it is called as a 5 prime UTR and the 3 prime UTR. It is always present at the RNAs, guys. Okay, so mRNA is always having the 5 prime and the 3 prime UTR. So the Shandal-Garner sequence is here somewhere. It's a site of ribosome binding. Ribosome binding. Where the ribosome bind is your Shandal-Garner sequence. Okay, in a prokaryote. So you already have in this question. G capping. It is again the ribosome binding site. In eukaryote. In a eukaryotes. Okay, so let's see the next question. Which of the following is correct about the oval pairing? So first of all, let's see what is meant by oval hypothesis. So oval hypothesis is about the wrong pairing. I already discussed it in a very first 2-3 questions. Okay. So non-complementary proteins, non-complementary pairings. It is about the wrong pairings. The first position tolerate the mispairing than the second and the third. So it is about the, for example, mRNA, which is having the 3 code here, and this is a tRNA, which is having anticodons. Okay, somewhere in the sequence. First, second, and third. Okay, so if I zoom it, so for example, it looks like A, U, and G here. So the anticodon should be like a G in the front of a C, U in the front of A, and A in the front of a U. Okay, but if you say the G maybe looks like this. Okay, so this is a third codon, third position of a codon. Okay, so the third position tolerate the mispair than the first and second. Yes, absolutely. The correct answer is the third position mispairs more as compared to the first and the second. So this codon is called as oval position. Oval position. Okay, and it's a oval hypothesis actually. Sometimes the codon is not correct. Still, amino acid is a code. Okay. Next one, in the process of a translation, the translocation is, what is meant by the translocation? Guys, translocation is yes, correct. It's a movement of tRNA. Okay, it's a movement of tRNA. But from where to where? So if you say the ribosome, for example, this is ribosome. I'm going to be draw it very larger, so we can draw the sites. It's a site where the entry of a tRNA happens. tRNA enters. Okay, then it's a second site. We call it a P site. It's a peptide bond making site. Okay, it's a bond making site. And the last third site is here. We call it a E site. A tRNA come out from here. So exit site. Okay. So in this site, first of all tRNA comes here, then it jumps from here to the here, and the final jumps here, and then come out of the ribosome. Okay, so the translocation is a process in which tRNA is moved from the A site to the P site. Okay, So it's a A to P, A site to the P site. It is called as a translocation. It is very important thing, guys. When tRNA transloc from the one side to the second side, actually the peptide bond is formed. Okay, and it is very important thing in the making of a protein. Your answer is A side to the P side. The second one is a more correct. Okay, second one is a more correct. Your tRNA never enters. I mean, never jump from the A side to the direct E side. Okay, A to E, direct A to E will never happen. So it will definitely spend time in a P site to make a bond. Okay, so at the P site, actually the bond is formed. Okay, this is a very important site. You can say the making of a bond. Hypothetically, mRNA shows 90 nucleotide, which codes for. So let's see, for example, it is started from here. So 1 nucleotide, 2 nucleotide, 3 nucleotide, 90 nucleotide. So here is your 19th nucleotide. Okay, so it's a 19th nucleotide. It codes for, obviously, the 3 nucleotides comes together to form a 1 codon, and 1 codon is equal to 1 amino acid. So the 90 nucleotide, 30 codon. It codes for not 30, 29 amino acid. Why? Because the last one is a stop codon. It's a nonsense, guys. It is not code for the any amino acid. Okay, so it's code for a 29 amino acid. So please always keep in mind that stop codon codes for nothing. It codes for nothing. No any amino acid is coded by the stop codon. It just stop codon. It's just going to be a halt the process, going to be a stop the process. Okay, so it is not going to code for any amino acid, and that's why the last codon is non-productive. So your amino acids count always -1 than the number of codon. Okay, there are 999 bases in a RNA, so obviously they are talking about mRNA here. Okay, that codes for 332 amino acids. Okay, so the 999 based mRNA is here. Okay, nucleotide mRNA is here, first codon and the last codon. 33 amino acids, so this last codon is a stop codon, they already told us. Okay, if codon number 991, okay, so for example here close to the codon number 991 is deleted such that where is yeah, such that the length of RNA become 998 bases. Actually not a codon number, if the nucleotide number or the, okay, codon is also correct, but let's say the nucleotide number, and that's why the codon your complete nucleotide RNA become the 998 bases. Okay, so the now one base or the nucleotide base or the nucleotide is deleted, so we do not have now 91. Okay, so we have 990 here, and direct 990. So for example it's a 990, and now we have now 992. Okay, so the complete sequence is now going to be reduced 999 to the 998. Okay, so the one nucleotide, one base is absent here, and due to that, what happened? How many codon will be the altered? How many codon will be the altered? The only one codon is going to be altered, but because of that, guys, what happened? the for example this 991 wala is not here now. Okay. So because of that, what happened, till the 990 we do not have any problem. Okay. But at the 991 is going to be a mix with the another one, and that's why what happened, let's see. So for example, it's a codon of, it's a base of 990 and it's a codon. Okay, because codons are the uh, group of three bases, so they always comes together. And now the 991 is not there, but if you see when the 991 was there, 991 was there, so it was one codon like a 991, 992 and 993. Okay, now it's a 991, 992 and 993. So now 991 is not there. Let's say 3, then 4, 5, 6, 7, 8 and 9. So it's the last one, 999. Now 1 is not there, and because of that these 2, 3 and 4 actually going to be comes together as a one codon. So after the 4, 5, 6 and 7 is going to be a one codon, and the last group is going to be a one codon. So only 1, 2 and 3, three codons going to be a change, and that's why how many codon will be altered, so the only three codons will be altered, so the answer will be a 3. Okay, so the answer will be a 3, not 33. It was just a mistake, guys. So answer will be a 3. So we can see here. Okay. Actually 991 is going to be a change, and that's why the complete process, the the complete process which is moving ahead of a 991 is going to be a change, because codon now the is altered. Okay, so always a deletion codon or the addition sorry, deletion mutation or the addition mutation always having its effect on the making of a protein. Okay, so please keep in mind that if there is a deletion of any code or the addition of any code, it will definitely change the sequence of amino acid in the particular protein if it's a gene. Okay, so guys, thank you very much. And I mean the whenever we start from tomorrow, we are going to be start again the 9 p.m. also. So not tomorrow, today. Okay, today we have a 9 p.m. The syllabus plus the other things like the deleted and the importance for 2021 MST CET. So we have a lecture at 9 p.m. Okay, so from today we are going with a new syllabus and the important things about MST CET 2021 at the 9 p.m. and the same lectures at the 7 p.m. Same means the for 2021 also. Okay, so I am here on this channel Maharashtra CET live at the 7 a.m. and 9 p.m. Okay, and this channel will give you the link, and when you are taking a subscription, at the time of a subscription, if you use this capital Abhijit, it will give you the 10% discount in the fee. Okay, so thank you very much guys, and uh, have a good time. Bye bye.